Yo, what's going on, man? This is going to be our first video lesson of the semester, guys, and we're going to cover imaginary and complex numbers and their roots. All right, I am your host this afternoon, Coach Moore. Hey, I hope you find this helpful. If you do, man, please make sure you subscribe to the YouTube channel. That way you can get the notifications when I upload new videos, which is going to be every day. Also, at the end, I will be showing you guys some answers to a couple questions, so you'll have those as a reference for later. If at any point, man, you have a difficulty with the video, you don't understand something, just rewind it, man, and check it out again. I'm going to try to explain as clearly and as detailed as possible, okay? So let's get started. A couple things that I want to talk about is the standard here, guys. What we're doing with this standard, guys, is I expect you to know that there's a complex number I. All right. There's a complex number I, and if you square that I squared is -1. All right. That's our objective for this whole lesson today. Again, man, I squared, or there's an imaginary number I. All right, that every time it is equal to -1. Okay. Now, we get right here to this right here, this I know that the square root of -1 is I. All right, anytime you see this number right here, the square root of -1, you're always going to say that that's I. All right, the square root of -1 is I squared is -1. These are just things that you want to remember, okay? You want to remember that. The math behind it is really simple. If I were to square root, if I square root right here, so you can see it, all right, the square and the square root would cancel, and I'm left with I, all right? So it would just be I, the square root. So that's neither here nor there. What you want to do is you want to learn that the square root of -1 is I, and also I squared is -1. Okay. Now, what is an imaginary number? Is the first question. What is an imaginary number, Coach Moore? I want to know. All right. Well, an imaginary number is basically right here. There are no x-intercepts. You guys have graphed in Algebra 1. You've graphed in some other math classes as well, and you've read graphs in science or whatever. But there's no x-intercept, meaning that here's the x-axis. All right, this graph does not touch the x-intercept. All right, but mathematically, when you solve it, you end up with an imaginary number. Okay, you can solve for an x, but the number's not real. All right, it's imaginary. And right here is an example: x squared plus 1. If you were to solve this for x, all right, you would subtract the 1 on both sides, and you'd have x squared equals -1, and then you would solve for x by taking the square root of both sides. All right, now when you take the square root on both sides, that cancels to leave you with just an x, and x would equal plus or minus the square root of -1. All right, well, again, guys, the smallest possible square root ever is 0. All right, if you took the square root of 1, it would be 1. If you take the square root of 0, it is 0. There's no such thing as a negative root. That's why it's imaginary. All right, and remember we said that the square root of -1 is I. All right, so again, there's no such thing as a negative root. It's going to be imaginary. Here's what I mean by that. Like, let's say if I said -2 squared. All right, if I took -2 and squared it, that would be +4. All right, if I took 2 and squared it, that would still be +4. I can't take the square root of this number and get that negative back. All right, if I take the square root of this number, I'll end up with 2. Okay, now that's about 5 minutes, man, of just some general knowledge stuff. All right, so again, back to the top here. Remember, the square root of -1 is I, and I squared equals -1. All right, you remember those things, you'll get through 1.1 with a breeze. So let's go ahead and dig in. An imaginary number is I is defined as the square root of -1. So anytime you see the square root of -1, you remember that it is I. All right. So now, here's a little chart right here. All right, this is for you to reference when working on the U-tries and when working on the actual assignments that we're going to do in class when you guys come back to class tomorrow. All right, and let me make this a little bigger so I can write in it. All right, so the first one, again, the square root of -1. If you remember, the square root of -1 is I, okay? Well, right here, the square root of -2. All right, we can't solve this. There's no square root of 2. All right, but what we can do is see this negative. We're going to separate this. All right, we're going to factor this radical to be the square root of 2 times the square root of -1. All right. So now, and the reason I separated, I factored is because 2 times -1 is -2. Okay. So now that we did that, we separated it, we factored it. All right. Well, we have this right here, the imaginary number, the square root of -1. When you have the square root of -1, we can say that is I. All right. And so I have I times the square root of 2. And this right here, this would be the simplified answer right here, guys. All right, so the square root of -2 is I square root of 2. Again, the reason being, if I factor this into 2 factors, one being the imaginary number and one being the real number, you see that the square root of -1, the imaginary part, is always I. Okay? Have another look at this other example right here. The square root of -4. Well, there's a negative right here, okay? So what we're going to do is factor that again, all right? So we factor that, square root of -4, you get 4, and the square root of -1, okay? Anytime there's a negative, factor out the square root of -1. Reason being is because that -1 is I, all right? And then the square root of 4, guys, we should know what the square root of 4 is. That's 2 times 2, of course, which is 2. So we end up with the square root of -4 is actually 2I. All right, 2I. It's 2, the square root of 4 is 2, but it has an imaginary part, which is I. So we say 2I, okay? And finally, this last example right here, we have the square root of -1. All right, well, we know that the square root of -1, remember we talked about it right here, the square root of -1 is I. So we actually have I squared, okay? I squared. And I squared, guys, now you take the I squared, we talked about it up here. Oops. The very beginning of the notes, we said that I squared is equal to -1. And again, it's just general rules that you learn, all right? You want to learn, put those in your memory. I squared is -1, okay? All you gotta do is learn it. That's not hard. That's not hard to remember, guys. If you learn that I squared is -1 and the square root of -1 is I, man, this will be a breeze, okay? So let's look at a couple more examples here that we can work out. Again, if you at any point, man, you're stuck, you're like, man, I don't get it, just rewind it, listen to it again, okay? Right here, we're going to simplify square roots of negative numbers. Express the number in terms of I. All right, which means we're going to pull out the imaginary part. So I will be in the answer, guys. When it says express the number in terms of I is in the answer. Okay. So with that being said, let's see here. We have 5 times the square root of -121. Well, quick side note, if you remember, 11 squared equals 121. All right, if you had your calculator on you, you could do that. 11 squared is 121. Okay. So what I'm going to do is I'm going to write down all my factors here. Okay, I'm going to factor like we did up here with the square root of 4 and the square root of 2. I'm going to take the square. I'm going to factor this 121 or the -121. So I have 5, which is from here, and I'm going to factor the square root of -121 into its positive 121, so it's no longer negative, and the -1. Okay, again 5, which is right here, and then I factor this radical 121 times the square root of -1. Okay, so now I have a square root that I can actually solve. Okay, the square root of 121 is 11. Okay, it is 11. So I'm gonna have 5 And you guys remember, this is multiplication. All this is multiplication. These are factors of that. So 5 times 11. And again, the square root of negative 1. The square root of negative 1 is always I. Okay? So now we just got to put all this together. We have 5 times 11 times I. Well, 5 times 11 is, hold up, I don't want that to look like a 7, guys. That's an arrow. There we go. All right, 5 times 11 is 55. And I is just I. So the square root, 5 times the square root of 121 is 55I. Okay. All right. This next example here, we have negative. So since there's a negative right here, just hanging out by itself, we're going to go ahead and make that a negative 1. Okay. So we have negative 1 times the square root of negative 96. Okay. Negative 1 times the square root of negative 96. So again, we're going to factor this. Okay. We have negative 1. Okay. Negative 1 times, factor this out, guys. Take out the negative. So negative 1 times the square root of 96. Okay. Now, 96, guys, let's talk about that. That's not a perfect square. Okay. If you had to write out your perfect squares, well, and you just think about it, we know that 8 squared is 64, 9 squared is 81, 10 squared is 100. Oops, 100. All right, so we know that since this is in between 9 and 10, that's not a perfect square. So what we need to do with this 96 is factor it again. All right, we need to factor this 96 again, and here's what I mean. We got to think of perfect squares. What perfect squares do we know of? All right, I know that 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared, 25, 6 squared, 36, 7 squared, 49. Okay. So now we're going to look at these perfect squares. All these perfect squares. Okay. Now, one of these perfect squares, 10 perfect squares, is a factor of 96. All right, which means that if I multiply one of these numbers, one of these perfect squares by a number, it'll give me 96. All right, now I'm gonna go ahead and show you which one it is. We have negative 1 times the square root of negative 1 times 96. We can break that down. We can factor that into the square root of 16 times the square root of 6. Okay. Because 16 times 6 is 96, okay? And again, the reason we did that is because, see this 16? That's a perfect square. We can solve that. We can solve this one. We can simplify this one. We can simplify that to 4. Remember the square root of negative 1, we can simplify that into I, and we still have the negative 1. And the square root of 6, remember, is not a perfect square. So we're going to keep that. So now we just need to multiply what we have. We have negative 1 times 4 is negative 4 times I. And we keep the square root of 6 because this doesn't simplify anymore. All right. If you look back at our chart that we made, 2 squared is 4, 3 squared is 9. So the square root of 6 doesn't break down. There's no factor 6 that's a perfect square. But see, like 96, the factors of 96, there are perfect squares. All right, so now we're at the U trisection, okay? And with the U trisection, guys, what's going to end up happening is you're going to actually try these, and I'm going to provide you with the answers, but not the solutions. All right, and what's going to happen is it's on you to try them, all right, as you watch the video, and then come to class the following day and then express where you got stuck at. All right, now this is important, man, to your success, because I need you to practice so I can see your errors and your dilemma. I don't want you to just write the answers down because I can't help you. I really want to help you and see you succeed. So you got to try them, and it's okay, man, if you don't get what I got. It's important that you try and let me see the work, so I can address where you went astray, all right, where you messed up, okay? So try these. Again, I'm going to put the answers up at the end of the video for all the you tries, and then you just practice, okay? You practice. But I'm going to go ahead and jump to the next part of the video, solving the quadratic equation with imaginary solutions, all right? Solve the equation, okay? Now, right here, what's going to happen is we're going to solve these. You're going to get imaginary numbers, and we're going to check ourselves after that, okay? So, let's go ahead and dig in, man. This first part right here, we have x squared equals negative 144. You guys have solved equations, so hopefully you remember that when you solve for x, right here, when you take the square, well, let's first address it. I want to solve it for x. So to isolate x here, I need to get rid of this square right here. This is x squared. Well, to get rid of the square, I'm going to take the square roots of both sides of the equations, okay? Both sides of the equation. So when I take the square root on both sides, this cancels the square roots, and the square goes away. They cancel, they negate each other, so I'm left with just x. Now, whenever you take the square root on both sides, guys, you're always going to have plus or minus. This goes with this step every single time. Whenever I take the square root on both sides of an equation, I instantly get plus or minus. All right? So now I have plus or minus the square root of negative 144. Okay? So now, just like we did on the last page, I have x equals plus or minus the square root of negative 144. We're gonna factor this, all right, or separate it, okay? So I have x equals plus or minus the square root of 144 times the square root of negative 1. Remember, factor out the negative, okay? Factor out the negative. So now we can reduce it or simplify it. So we have x equals the square root of, don't forget my plus and minus. The square root of 144 is 12. And the square root of negative 1, guys, we've been talking about it. That gives me the imaginary number is going to be I. So we have x equals plus or minus 12i. Okay. Now to check myself is simple. All right. Remember, x is plus or minus 12i. So we have two answers. We have x equals plus positive 12i. And we have x equals negative 12i, okay? So I'm just going to check both of those. If I took 12i and squared it, all right, we know that 12 squared is 144. And we know that I squared, remember I squared, you got to square everything in here. I squared, if you remember at the beginning of the notes, we said that I squared is negative 1. All right, so from there, we can multiply to get negative 144. Also, if you were to check the negative 12, see that's plus or minus, so you have positive 12, negative 12. All right, negative 12i squared. Again, negative squared, if you square a negative number, it becomes positive. So negative 12 times negative 12, a negative times a negative. All right, it's going to be positive 144. And again, I squared is negative 1. So if I multiply those, I end up with negative 144, which is what we originally started with way over here, negative 144. All right, so it checks out. Okay. Good habit right there to check yourself, guys. The reason you do that is just to see if you made an error somewhere. All right, check yourself. Good practice right there. All right. Another example right here, 2b. We'll get rid of this so I can have some more space. All right, 2b. We're going to solve this for x. So we're doing so, man, what we're going to do is we're going to first subtract 90 on both sides. So we have 5x squared. All right, we're going to minus 90 here. So we have negative 90. And then we're going to divide by 5. So we have x squared equals negative 18. Negative 90 divided by 5 is negative 18. All right, next we need to take the square root on both sides. So we want to get rid of this square here. We're going to take the square root on both sides. So take the square root here, take the square root here. Remember, once you take the square root on both sides, guys, you're going to have plus or minus. So we have x squared, or excuse me, not x squared, we have x equals plus or minus the square root of negative 18. Now, let's simplify this, okay? Let's factor out our negative 1. So we have x equals plus or minus the square root of 18 and the square root of negative 1. All right, we factor out negative 1, so now 18 is positive. Now, the next thing we need to do is see if there's a perfect square within 18. A factor of 18 as a perfect square, and it is 9. All right, so I'm going to factor 18 now into 9 and 2. All right, 9 times 2 is 18. And we still have negative 1. So now I'm going to simplify, guys. I get x equals plus or minus. The square root of 9 is 3. The square root of negative 1 is I. And the square root of 2 is just square root of 2, okay? So here is our answer, okay? Now, we got to check ourselves. All right, and how we do that is we're going to plug this back into our original equation. So we have 5 times, I'm going to go positive 3i first. Square root of 2 squared plus 90, and it should give me 0. All right. Well, I square this, that's 9. I square that. All right, that's going to give me negative 1. And if I square that, that's 2. All right. So I have 5 times everything in the parentheses plus 90 equals 0. Well, 9 times negative 1 is negative 18. 9 times negative 1 is negative 2. Negative 2. Man, I'm sorry, guys. 9 times negative 1 is negative 9. Negative 9 times 2 is negative 18. And negative 18 times 5 is going to be a negative 90. All right. So we have negative 90 plus 90 equals 0. And that's true. Negative 90 plus 90, guys, is 0. So this is true. All right. Even if you made this negative, all right, you're going to get negative 3 squared is still 9. I squared is negative 1. And the square root of 2 squared is 2. 9 times negative 1 is negative 9. Negative 9 times 2 is negative 18. And negative 18 times 5 is negative 90. So we get back here again, guys. So this is check. Now again, there's a you try. All right. You practice those, and then you just bring them to me, and we'll go over them in class. Okay. Lastly, I want to talk about the imaginary numbers. Okay. I to the 0, guys. Anytime, any number, it could be 100 to the 0 power. It could be 1,127 to the 0 power. All right. It could be 1 billion to the 0 power. All those will equal 1. All right. Anything raised to the 0 power, guys, is 1. All right. So make sure you know that. That's a general math rule. All right. Any number raised to, that's a D, the power of 0 that's a mathematical property right there that won't change ever. All right, any number raised to the power of 0 is 1. Okay, that's just something you want to know. All right. Anyway, so I to the 0, all right, is 1. All right, it's that simple. I to the 0 is 1. I to the first. All right, think about it. If I had 1 to the first power, it would be 1. 2 to the first power is 2. So I to the first power, guys, is I. Okay. I squared, guys. Well, think about it. We already talked about it also. I squared is -1. All right. I cubed. Now think about this. These are 3 i's, right? So I'm going to break it down like this so you can see it. I cubed is I squared times I, right? Well, we know I squared is -1. That's -1. And we know that I is just I, right? All right. Again, what I did was I took I cubed, I factored it to I squared and I. Well, we know I squared is -1. All right, and I is just I, so we have -1 times I, which is -I. And lastly, we have I to the 4th. Well, that's I squared times I squared, right? That's 4 i's, 2 and 2, 4 i's. But we know I squared is -1. So -1 times -1 is a +1, okay? +1. So now, why did I do this? I'm trying to show you a property that I think will come fairly easy if you continue this table. All right, if you were to continue this table, what would the pattern be? The pattern would be just like this. 1, I, -1, -I, 1. All right, and then just continue infinitely for every number. All right, you would go 1, I, -1, -I, 1. All right, so again, 0 powers. Let me write that down. Power of 0, power of 1, power of 2, power of 3, power of 4. Now, the reason I wrote this process for you right here, if you learn these powers, you can solve any number, even if it was like I to the 1,337. You could figure out what the answer is going to be. All right, if you learn this pattern. All right, so 1, I, -1, -I, 1. Start over again. 1, I. They're both positive. -1, -I. They're both negative. Then back to 1. Now, let me show you what I'm doing with this, okay? What I'm using this for, all right, is solving large numbers, all right, large properties of I, okay? So take this first one, say 99, okay? I to the 99th power. We know that the number 99 is divisible by 3, all right? In fact, we know that 3 times 33 would give me 99, but that doesn't even matter. I know that 99 has a factor of 3, the power of 3. Well, I cubed is -I, so I to the 99th power would equal -I. Okay? Right here, I to the 17th. The only factors of 17 are 1 and 17. So the only power that I see that's in common with our chart is the first. So I to the first is I. So I to the 17th is I. 4I to the 120th. Well, I'm going to put 4 to the side here for a second, but I want to talk about I to the 120th power. 120 is divisible by 4. All right. This is divisible by 4. Okay. So, since I can divide this by 4 evenly, I can say that this is, see this table? I to the 4th equals 1. Well, I to the 120th, since this is divisible by 1, since this is divisible by 4, equals 1. So I have 4 times I to the 120th, which we said is 1. I to the 120th power is 1. We have 4 times 1, which is 4. Even over here, we have I to the 64,002. Okay? Let me show you a little calculator trick real quick. So right here, this is called a quarter method. I'm going to show you with the calculator how you can solve this portion, or you'll know which chart to use. Okay. So we have I to the 64,002. The quarter method says there's 4 quarters in a dollar. All right. And you can use the remainder of the exponent divided by 4 to determine which power rule of I you will use. So when you look at this 64,002 and divide it by 4, we get 16,000.5. All right, 0.5 is the remainder. All right, or that's like 50 cents. All right, or 2 quarters. 2 quarters. So if I go back to my table, we said 2 quarters. See where the exponent is 2? That's negative 1. All right. Again, 64,002 divided by 4 is 16,000.5. 0.5 is 50 cents or 2 quarters. All right. So 2 quarters or 2 as the exponent is negative 1. So what we're saying here is you have 1/4 times negative 1. All right. I to the 64,002 is negative 1. So the answer here is actually negative 1/4. Negative 1 times 1/4 is negative 1/4. Just to show you, if we were to check this, all right, 120 divided by 4. All right, again, you can use the calculator. If I take the exponent of 120 and divide by 4, it's just 30. There's no remainder. All right, no remainder. So if we go back to our chart, no remainder, 0. All right, 0. The answer is 1. So I to the 420 is 1. So I have 4 times 1 is 4. All right. If you look at I to the 17th, take 17 and you divide that by 4. 17 divided by 4 is 4.25. Well, that's 1/4, 25 cents. 1/4. So if you look back at the table, where the degree is 1, it's I. All right, it's I. So you have I to the 17th, which is I. All right, so that's the quarter method. So now, guys, try these that you try. All right, and as stated, I am going to provide you with the answers for all the you tries. So let's see here. Here are the answers, guys. Take your phone, take a picture of it or pause it, work through the problem, see if you get the same answer. 1A, 1B, 1C, 2A, 2B, 2C, 3A, 3B, 3C, 3D. All right. I do quick checks and homework checks. So make sure you get this done. Just practice. We're talking about 10 problems, 10 total problems. Practice those 10 problems. Then come to class and talk to me about where you maybe didn't get the same answer or what's bothering you with the assignment. And just tell me how I can help. And I am more than grateful to assist, okay? Well, that's my video, man. See you in class.